Okay, so number 15 says, answer the following to find the exact zeros for the polynomial. We might use a quadratic here, we shall see. But what I want to do first is, part A, show that the synthetic division is going to basically factor this out. And we're going to use, okay, x is the solution of the third degree polynomial. We're saying x equals 3 is one of the solutions. Otherwise, one of the answers, aka x-intercepts, aka zeros of the function. Okay? So I can write this in factored form like this, x minus 3. So if this works, we're trying to see what would it be as a result of it working. Okay, so let's do some synthetic division. We have coefficients of 1, negative 10, positive 25, and negative 12. And we're saying that this worked. That means this factor is going to be written. Okay? But when we're doing synthetic division, in this box, we are going to put the x-intercept. We're not going to put this number here. Okay? I want to make sure that you're loud and clear on that. We're going to put the 0 of the function, otherwise this x equals piece. So that's why we're going to put 3 here. In synthetic division, we always copy the first number down, then multiply. So this 3 and this 1 gives us 3. Then we add. So we get negative 7. This 3 times this negative 7 gives us a negative 21. We add. We get 4. And then 3 times 4 will give us 12, which ding, 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 we wanted a 0 here. Because remember, we're adding these. So our leftover pieces are this 1, negative 7, 4. And let me show you something real quick. This constant x squared, and x cubed is now going to shift over to the left 1 down here, so that this is our new constant. This is our new x, and this is our new x squared. So we have a positive 1x squared, a negative 7x, and a positive 4 left over. This is what we got as a result of this 0 actually working. So let's go ahead and write this in factored form now. Now this is the confusing part a little. Because positive 3 worked, we're going to write this as a factor that worked. Okay? Because again, that positive 3 says that it would go here to make this binomial 0. Alright, so now all I have to do is factor even further, because it said using that synthetic division, show that the given x value is a solution. So that's it actually. That's it. We don't even have to go further. We showed it right here with the remainder being 0. Okay? So there, in fact, we showed it with that remainder being 0, and we'd be good to go for part A. Now, part B says, from the depressed, otherwise reduced quadratic factor, find the other irrational or non-real solutions. So this reduced quadratic that they're talking about is now this reduced form here. And we're going to try to factor this to find the other zeros. Okay, a couple ways you could do this. Something called the discriminant test. Okay, the discriminant test is that we can look at a piece of this quadratic formula, otherwise b squared minus 4ac. Okay, so over here b is negative 7, a is positive 1, and c is a positive 4. So if I do a b squared minus 4ac, I get 49 minus 16. The fact that this is positive shows that you will have 2 real solutions, or 2 real zeros, if you will. Okay? That means the quadratic, whatever it looks like, will in fact cross the x-axis 2 different places. 2 different distinct places. Okay? It will not double root bounce, meaning it only has one answer that's duplicated. That would look like equals 0. And it, of course, does not look like an imaginary quadratic where it would never cross. That would be whenever this discriminant test is less than 0, otherwise negative. Okay? So just a good way that you can use that discriminant is that you know you're going to find something that has 2. So if there are 2 real roots, we can factor this by hand. Okay, and from the other videos that I showed you, we're trying to find these x's will give me x squared. Now I need factors of 4. I get 1 and 4 or 2 and 2. Now what we talked about with other videos in this review, these will become 5 when added or 3 when subtracted. These will become 4 when added or 0 when subtracted. We want a -7. And because none of these are -7 tells us we're going to have to use quadratic formula, okay? So because we did not actually get those numbers to work out, we have to use this quadratic formula. Okay, so let's go ahead and begin. We have a -b plus or minus the square root of b squared. Be careful with parentheses here or you will miss it. This is, the negative goes in on the inside with parentheses. So b squared minus 4a and c was 4. All over 2 times a. And again, that a, b, and c pieces that we looked at before were from over here by analyzing this reduced quadratic factor. Okay. So now I always tell my students it's probably best to analyze what's underneath the radical first. So everything that's underneath here we're going to solve, which we got 49 minus 16. So 49 minus 16, you get 5 and 3. You're going to get the square root of 35. And this negative times a negative is going to result with a +7. And it's all over 2. Okay, so the question is now, can we reduce this radical of root 35 to something that can be simplified? Alright, so trying to simplify the radical of 35 means that we have to try to do prime factorization. Okay, so prime factorization meaning, oh, and I made a mistake, I just noticed. 9 minus 6 is not 5, it's 3. So this is actually the square root of 33, not 35. Let me change that real quick. Alright, so 33. So can you take the square, or can you reduce or prime factor 33? Again, what we learned in class, we can try to break down 3 by dividing by 2, which we cannot get. We can do it by dividing by the next prime number, which is 3, and we get 11. But we are noticing that we're not going to be able to bring out the square root of 3, because we don't know what the square root of 3 is. And we're not going to be able to bring out the square root of 11, because that's not like a whole number integer. So this would be, in fact, the factors that we would get for our answer, because we can't simplify it any further. So it says, from the depressed, find the other irrational or non-real solutions. Well, we have an irrational right here. If they were non-real, they would actually include the I piece right there. Like there would have been a square root of a negative over here that would have come out as an I, but that's not the case here. We just have the irrational factor form.